Begin by opening the CombiRx infection subset data, and you can have that open while we walk through how to do some things in JUMP that are associated with the chapters and sections of notes that you've just read. So here is the data set. You can see that there are 334 observations. That's down here in the lower left-hand corner. You can also see that we have a number of different variables that we'll be utilizing with this data set. The first column is the ID number of the participant. We then have ethnicity, race, and gender, which are categorical descriptors, followed by age group and baseline, weight in pounds, height in inches, and the BMI of the participant. Those are numeric variables. You can see here that the numeric variables have the blue triangle. The categorical variables have the red small histogram. And the ordinal variables, those that have an order to them, categorical variables with an order to them, have the green histogram with the bars going in order. For each of our types of infection here that the participants were asked about, we have presence or absence of the infection, as well as the age of diagnosis for the infection. So the first thing that you generally want to do when you are opening a data set or looking at a data set is to do a distribution of all of your variables. In the distribution window, you can then check to see if you have any missing information, if there are any potential odd, erroneous, or outlying observations, and get a general feel for what is in the data set that you have. This will go a long way towards helping you answer your question with the data if you are familiar with the data. You don't simply want to jump into the analysis because you could miss some things that may potentially be wrong in your data or might potentially cause problems. I wouldn't recommend doing a distribution of all of your variables at once. That can be very overwhelming. For example, if I do a distribution, so if I go into the Analyze menu and click on Distribution, or if I use the Distribution shortcut and I put all of my variables in the Y area, and to do that quickly, I can actually press the Shift key. So select ethnicity, press the Shift key, and select the last variable. That will highlight all of them, and then press Y. Or you can do them one at a time. But to demonstrate, if I put them all in, you'll see it even stretches outside of the window that I have, and it's very hard to keep track of what you're working with. So I suggest that you do variables in groups as you are attempting to assess or get some summary information for those variables. To begin with, let's start with our categorical descriptor variables of ethnicity, race, and gender. One of the shortcuts in JUMP is to go ahead and select variables in the data set. You can either do that by selecting the columns, or you can go over here to the columns menu and select them here. And then again, do distribution, check Y, and press OK. And that will bring us to the distribution of our ethnicity, race, and gender. This is where you can get the counts, or the N, as well as the probability is what JUMP calls it, but it's the proportion of each category. JUMP will display them in alphabetical order. If you'd like another order, you can change that in the columns menu for that particular variable. There will be more on that in future JUMP videos. For now, this is fine. We can see here in our ethnicity that we have Hispanic, Latino, non-Hispanic, non-Latino, and unknown. For race, we have African Americans, Caucasians, and other. And then for genders, we have female and male. And you can see the associated counts and the probability or proportions for each of those designations. Don't see here any strange observations, but for example, if I change this observation to a small m and then do another distribution on gender, you can see I'd be able here to detect the difference in the small m and the capital M. JUMP does use capitalization to differentiate between variables, so make sure that you are careful when you are collecting your data or entering your data, and then always check your distributions. Let me go ahead and change this back to a capital M so that we are back to the distribution of our categorical variables. So this gives you the individual frequencies of each of the categorical variables. From here, we can actually look at the continuous measures that we have. So I'm going to select age at baseline and do a distribution on age at baseline. So this is when a participant comes into a study, their age is assessed. And you can see here that we have a histogram from JUMP. I'm going to click and drag to make this a little bit larger. This is the basic histogram from JUMP, and what you can see here is that it gives you a bar or a count for each level that we have. Now, what we aren't seeing are the actual counts. This is something you can change in JUMP. So if you look at the display options and then the histogram options, you can actually add a count axis. So down here on what would be our x-axis, it's added the counts. You could also actually show the counts. And so it will then tell you how many participants or how many rows of data are within each histogram bar. So there's only one person that is under the age of 20. One of the very neat things about JUMP that I like is that if I select this one person, you can see that JUMP then selects it in the data set. If I go up here and select the two that are over the age of 60 and go back to the data set, I can see here that I have two over here in the lower left, that I have two rows selected. And I can scroll down to find those participants, or under the rows menu, I can go to next selected and it will take you through them. This is a very easy way to identify outlying observations if you need to find something that is somewhat problematic. To undo this that I've selected here, I can hold the Shift key and click on it again. Excuse me, I can hold the Command key in Mac or the Shift key in Windows to undo it. So if I click it in a Mac to undo it, I hold Command and click again, and then in Windows you can hold the Shift key. Now we've also got the box plot here. This is default with JUMP, and it will show you a number of things depending upon the box plot that you have showing. We can change the box plot that we want to show. So right now we have the outlier box plot. We could actually change it to the quantile box plot. If you wanted to see that, make that a little bit larger. And that, the quantile box plot is here on the left. That will show the different quantiles that are associated here. Or the outlier box plot, which is much more common. And then if you want to know more about the outlier box plot, I'm going to change my pointer up here in the bar from the arrow to the question mark. You have those options in Windows as well. If you view your drop-down menu, you can actually select the question mark, and then if I click over here, it will bring up JUMP Help, and it will show you what the different parts of the box plot are here in JUMP. So it's very, very helpful, that question mark icon, to change your pointer to the question mark, and then JUMP will open the JUMP Help for you. Now, in addition to the histogram and the two box plots that we have, we can actually take a look at what data summaries we have. We have the quantiles here. This is the percentages of data and the numbers of those outlines. So you can see the minimum here is age 18. This is our one person here. That is our age 18 that we saw earlier. Person number 13. Our 0.5 percentile is actually 19.4 years. These smaller percentiles or these higher percentiles aren't commonly referenced. What's most commonly utilized are the quartiles. That is your 25th percentile. So 25% of your participants are 33 years of age or younger. The median is your 50th percentile. 40 is the age associated with the median percentile. So 50% of your participants are 40 or younger. The next common quartile used is the 75th percentile. That's 49 years of age. And then, of course, the maximum is 60. When asked about the range of data, it would be 18 to 60. It would not be the mathematical range, which would be 60 minus 18 or 42. In statistics, we consider the range to be the minimum, comma, the maximum, not the mathematical difference. The median here is 40. Our mean, which is the average of all of these data points, is 40.5. And then JUMP also gives you the standard deviation. We have the standard error of the mean. We'll learn more about those later. And then we have the confidence bounds about the means. And again, we'll see those later when we start looking more in depth at continuous distributions. These are the basic distributions that you get from JUMP. Again, we looked at some categorical options. Let me pull up marital status here because it has more options. We can take a look at that. We have looked at categorical observations here, categorical variables where you get the count and the probability. And then we've looked at the continuous distributions where you see the histogram, and that is where you can get the box plot. You can pull your summary statistics, those things, the values that we put in the tables. So the n's and the probabilities, and of course to get a percent, you just multiply this times 100. Or the means and standard deviations, you can pull them out of here. JUMP also has a tables menu where I can do a summary of information. So if I wanted the summary of marital status, I could simply put it in group here, and JUMP would give you the counts. If I go back to JUMP has a tables menu, so you can collect summary here, and I could ask, put marital status in the group, and then from there you could get the percent of total and press OK. And then here you see that you now have the N and the percents of marital status. If I go back to my distributions, go to this table and go back to my distributions and put marital status in, you will see actually that we have the exact same results. So 34 divorced, and the tables gives you 10.2, whereas the distribution gives you the proportion of 0.1018. So again, to use the tables menu, summary, put marital status in the group, and then ask for the percentage of total of marital status, and press OK, and it will give you that, which you can easily put into a table. You can do similar things for continuous distributions. And by the way, every time that you see a column highlighted and then it goes away, I'm pressing the escape key, and that will take you back to nothing being selected. And you can just sort of continually press the escape key. So if I have one particular observation here, if I press the escape key, that will go away as well. So to go back to our distributions, again, I can do the distribution of my age at baseline and write down my mean and standard deviation, or I can use the tables menu and under select age and under statistics ask for the mean, ask for the standard deviation. If I wanted the quantiles, that's down here in the lower left hand corner, and I can put in the 25th percentile, so select quantile. And then if I want the median, I could type 50 in here, or I could simply select the median from the drop down. That is your 50th percentile. And if I'd like the 75th percentile, then I can change to 75th percentile here and ask for it for the quantiles. I could also simply ask for the interquartile range. That is what the 25th and 75th percentiles are called, the interquartile range, because they are in the middle of the four quartiles. And simply press OK. Now you can see here in the tables option, because we haven't done this by group, it's simply going to give us a single row. But what you'll notice here is that the mean age at baseline, 40.517964, matches this over here, the mean over here. Same thing for the standard deviation in the tables menu. It matches the standard deviation over here in the distributions menu. Same thing for the quartiles, you can see. And then what interquartile range here is given you is the distance or the difference between the 75th quartile and the 25th quartile. Again, we actually want the numbers, not the distance. There's many ways to get a 16. I could have a 50th or 75th percentile of 32 and a 25th percentile of 33. So actually having the difference of the interquartile range doesn't help describe your data. What we're really looking for with these quartiles is the distribution of the data. Is it symmetric? Is it spread way out? Is it clustered towards the center? And the actual values will help you determine that. So there are two ways to get summary data out of JUMP. One is the distributions menu. The other is the tables menu. They will give you identical information but presented in slightly different formats, and it is up to each individual JUMP user as to how they prefer to obtain that information. The key point here is to make sure that you start every data analysis by looking at the distribution of every variable that you plan to use to determine if there are any errors, if there are any outlying observations, if there's anything that needs to be corrected, if you have missing data, and to just become more familiar with your data set.